I mentioned, but we are looking forward to define the NZEB plan in every country, and also the EPBD recast milestones. So we need more impact, for instance, on standards, and SEN received a new mandate to evaluate the new standards with the focus of these buildings. And for 2020, so we have to achieve the goals, and of course the development in Europe for all new buildings of the concept of nearly zero energy buildings. And after, so we are here in 2020, so we define clearly the targets, but in fact the ambition is much, much, much more higher. If you look at the European roadmap defined last year in Europe, the target is to divide by 4, roughly speaking, the emission of CO2. It means, roughly speaking, one more time, dividing by 4 the primary energy consumption. It means for the building stock to reduce by 90%, roughly speaking, 90% the emission of CO2. So this is the real challenge. Can we achieve it? We have to discuss. So, near zero energy building is defined in the EPBD recast. It's a near zero or very low amount of energy required should be covered to a very significant extent by energy from renewable sources. So, in the definition, there is a balance between, let's say, the energy, the primary energy need of the building, and the on-site production of energy. So it's a change of paradigm, a complete change of paradigm. The building sector, which is the main energy consumer, is becoming energy producer. And this is the roadmap for the next 30 years. So, but what are the boundaries? What are we talking about? So, to define this, I propose to visit, in fact, all what we can integrate in the definition of the performance of a building. So the energy, the environmental impact, occupants, of course, and the overall environment. First of all is the intrinsic energy consumption of the building, which is focused. So we have to control property items consumption, but also all the equipments linked to the building. So we have to control movable property items consumption and to use, as I said before, on-site renewable energy. So what does it mean? So we have to define steps. For instance, this is the French roadmap, but I will use it in order to explain a little bit what we are doing. So we have existing building, the standard, let's say, building, optimized building. So with decreasing energy consumption linked to the conditioning of the building, the overall conditioning. And then we have the energy used by all the equipments we are using. So should we integrate this in the definition of the performance of the building? How are we using these equipments? Which are the standards that will define the quality and the performance on this? Assess the potential of renewables in different urban contexts. Of course, with different contexts, the potential renewable of use of renewable energy will change. It depends on the building. It depends, of course, of the location of the building. If you are in a very dense city center, or if you are in a rural zone, of course, the potential will be different. So how are we able to evaluate different levels of energy production? But another item, and it's maybe the first time we saw it clearly in France with the Observatory of Low Energy Building we launched a few years ago. the BBC Observatoire BBC, is that embodied energy is nowadays, with low energy building, playing a real role. It can be few years or even more than 10 years of energy consumption with very low energy buildings. So should we integrate it when we are talking about global performance of a building? So is it reasonable, for instance, to build in Turkey a wooden frame building with, I don't know, wood coming from Finland, for instance, by truck? So how are we managing this in a general definition? The occupant also, how can we give, which is the main target of building? We never build building to save energy. It's always what I am saying to my students. We are building buildings, they have to be comfortable, safe, and healthy. We are working for the occupants. And we have, of course, to manage the energy problem. So this is the main target. So we have to focus again on this target and also to facilitate the evolution of the behavior of the occupants. And this is a real problem. We have no real model for that. There is a lot of random behavior. So how do we integrate it in the overall evaluation of a building? Of course, we have to evaluate. So we need tools to assess, for instance, the impact of occupants on consumption, how they will use these buildings, and also maybe we have to communicate more in order to make changes in the behavior of the occupants via building conception and occupants information. Also, most of our buildings are not built on an airport, as I used to say. They have to be integrated in an urban context. So we have to ensure a good architectural and urban integration and control energy for users' transportation. Is it realistic to have a very low energy building built in the middle of nowhere, where you have to take your car every day to work at, I don't know, 100 kilometers from your place? How do we integrate it in the general evaluation? Another aspect is how do we integrate the real climate submitted to our building? This is the result of a European project we have been working on with colleagues from Greece. And what we show here that for the same office building built in the downtown Athens or in the airport Athens, the installed power to reach the same target is doubled. So how do we integrate the real urban context in the design of our buildings? So we have to think about it. Consider energy for mobility. It was what I was saying before. If you have an important mobility, how there is no pointer. Why? What I wanted to explain here, it's very nice to say, okay, we will develop, implement renewable source. But which is the target? If the target is to balance all the energy consumed by the building, our integrating embodied energy, mobility in this balance. What you can see here is that the consumption, let's say, of the building itself is becoming the small part of the problem. The bigger part is how we integrate, in fact, the overall definition of energy consumption linked to the building. So if you want to get the flower, you need the global evaluation. But global evaluation means multi-performance. So a huge work we have to do is to define what are, for every part, indoor environment quality, sustainable site, water efficiency, energy and atmosphere, material and resources, mobility. What are the indicators? And what are the metrics we want to use in order to evaluate the overall performance? We have already some. We have standards, general standards defined by CEN, ISO, national regulation. We have advanced standards, the new standards we are developing now for near zero energy buildings, for instance, but they are not enough. So we need more. So we have eco-labeling, which is developing, but we need to work and to have a common assessment on this if we want to succeed. Status of NZEB, they do exist everywhere in Europe. So we have already the first element, which is the best practice. So we can learn from this best practice, but the real challenge is to transfer this best practice from a niche market to the overall market. And this is the big step. So have we, what I want to focus on, maybe Eduardo Maldonado, who is with us, will point out this. The concerted action of EPBD, which is a forum where all the member states are meeting in order to evaluate the problems and the development of implementation in their national regulation, they opened a new chapter, which is near zero energy buildings. And in the first report issued this year, we have already some timeline in order to define the common targets. So we have the national work, we have the European work. Every country is contributing. I just picked up the elements I founded on few countries in Europe, but most of them, they introduced already this target in their new regulation. We have existing voluntary label, for instance. Minergie, F Energy in France, which is an NGO organization, Passive House, and they all define the new targets for low energy buildings. We had a huge work done by REVA, so we will have a panel at the beginning of this afternoon, so we will discuss in detail. I will not discuss in detail the REVA approach, which is merging now with the CEN approach in order to define the flux exchange between building and its environment. But if we look at the evolution of tools, for instance, for the last 50 years, we developed tools for energy models, we developed tools for IAQ models in recent years, which is very important. These two communities, they merge also. And now we have integrated system models. We have reduced order modeling for very specific elements. Design-oriented models, which is very, very important. The big issue of a project are the first element of the project, the first orientation. So we need models in order to evaluate since the very beginning the main orientations. We have some elements of occupant-oriented models, and we can use also models from advanced platform. So we need certainly more, but we have already a big panels of tools in order to predict the behavior of the buildings. In the last 15 years, I think the main elements of progress have been coming from materials, which have been developed 30 years ago, to integrate these materials in components. So it's exactly what we did, for instance, for high-performance insulating materials that you are able to use now, and for glazing and windows. Of course, the manufacturers, they did a lot of progress in the glazings, but the main progress has to be to integrate these new glazings in performing windows, with U of 0.8, even less now. The same for inertia. So we have a problem with overheating. Well, it's something which is coming. We can smell it. But we have some possibilities to use the inertia, the natural inertia of the building, or to integrate some specific materials like PCM in order to reduce, let's say, the effect of overheating by increasing the inertia. But I think that in most of the cases, they are much more efficient if they are integrated in components and systems. The same for specific materials like cool roofs or cool paints, for instance. Another element in the progress of the last 15 years is the evolution of the approach of indoor environment quality. We did, let's say, the way from set point conditions to the integration of the adaptive behavior of the occupants. So these are the work of Humphrey in UK or Didier, for instance, in Australia. And this has been already integrated in standards, even in the 15521, which will be discussed here. Another element is on IAQ. When Olifinger developed his concept in 1888, we were not able to evaluate the real IAQ because of the low concentration we are facing in indoors. So the idea was to evaluate it by, let's say, the evaluation of the perception. And it has been a big progress, in fact. But it's not enough. Now we are able to define target concentrations. WHO organization is working on it, and also various countries. Here I put the recent work done by the High Council of Public Health in France, which define target value. Target value are based only on sanitary problem, health problem. Some of that we cannot achieve right now. So we put it as a target, as a goal. And we put reference value for now and action value where you have to make some evaluation of the risk and to get a solution to your problem. So this is a big progress. Also in ventilation, from the words of our Swedish colleagues it was in beginning of the 90s, saying that build tight, ventilate right. That was the action pushed by the Swedish colleagues, but we are now doing that. All of this, we improve the airtightness of our building. And the airtightness of the building is very good for any system because you are giving the end to the system to improve the indoor quality. And so we have been working, a system can be natural ventilation also. It's not always a mechanical one, of course. Hybrid also. And there is a way now in order to improve also the evaluation of potential of ventilation for cooling. Because we know that we will be facing higher temperature in the future. Integrating environmental challenges, and recently, in the last 12 years, we have been a lot of development, and you can see that we have a choice of eco-labeling for buildings. I regret that we are missing some common action in this domain. If a company wants to build, for instance, here in Turkey, or in France, for instance, even more, so they are usually, if it's, let's say, a really performing building, they want to label it, so they will select the AICVF, which is the French label. But if they want to attract international company, they will need a BREEAM or a LEED or even CASB label. So I think we need more common action in this domain. And really, we have to work between us in Europe in order to advance in this domain. Cost optimality. This is a tradition. Each time we modify the thermal regulation of buildings in France, and I started as my PhD in 75, so I have been living all the regulation. Each time it's the same. It's not possible. The cost makes it impossible. And this is a courtesy of my colleague Franco Vorca in France. It's a study they did in 2008 on the evaluation of the cost. ICAD is a big promoter in France, and they have a huge park of building. And so what is very interesting, so the reference was the 2000 regulation in France. So 2005 regulation, you see it's roughly speaking about 1% difference. But the dispersion is much higher than the difference between the two regulations. And this is following. If you look for the passive construction, so it's near zero energy building at the end, in fact, well, the increase in cost is about 10, 11%. But the dispersion between the project is, roughly speaking, rather the same order of magnitude. So this means that the important element is not to build a low energy building, but how you design it, you build it, and you maintain it later. So these are the targets. It's no more possible to have a sequential design. You cannot have the architect building on his own and then calling the structure engineers and then sometimes HVAC engineers. It's no more possible. The big decisions, they have to be made at the very beginning. So we really need an integrated design of buildings with all the team around the table. Conclusions, few words. We certainly can achieve NZEB target for new buildings as we achieve the building performance evolution of the last 12 years in Europe. If you look at the step we did, I think I am quite optimistic. Boundary condition of the global performance evaluation needs still some work on common consensus. And we will have a panel discussion on this topic. Eco labels, they need to be standardized, or at least we need a common approach on this if we want to avoid the actual mess. Costs, they have to be severely controlled by the integrated design, in my opinion. And the major challenge still to come is the massive development on NZEB. It's not NZEB, it's near zero energy retrofitted buildings. This is the real challenge we are facing. So a strong effort in model development is still needed. Bertrand, a few minutes ago, said that we are linked now to the guarantee of performance. But guarantee of performance means that in the model, when you are designing your building, you need also some confidence interval on your prediction. Unfortunately, our community of modeling in the building, we are not used to this. If you look at other community, like aerospace, they usually always evaluate the risk of their prediction. So it's something we have to work. Also, we have to work on the integration of the surrounding environment, that's for sure, if we want to succeed. We need new metrics, because we are defining new criteria, so we need a common consensus for this multi-dimensional evaluation. Technology developments are necessary, in my opinion. We have now to go from components. We did the work from material to components. Now we have to go from components to systems, and integrated systems, as Bertrand said. And in my opinion, there is also a conceptual change which is needed. We really need to focus on the occupant. If we are looking, as I discussed before, on the behavior, on the importance of the behavior, on the mobility, for instance, on the exposure to pollutants. We cannot work as we do now. So we have to merge from the Eulerian approach, we take a picture of the building, to a Lagrangian one, which we are following the occupants, looking at his behavior. Well, thank you for your attention. So I think we are closing the session. Shafer, it's okay? Okay. If you have one question or two, I can answer. Up to you. Okay, so we are moving to the coffee break? Okay. So I invite you to the coffee break.
Kaç tane var Erbay'dan TTMD'nin? Kullanmadım herhalde.
almaktan başka bir şey kalmıyor evde. En iyisi kaçmak. Bence de. Kaçmak. Kesinlikle.
Talk about the integration of energy storage with nearly zero energy buildings and international research collaboration on the International Energy Agency project. Please.
Thank you, Mr. Chairman. My name is Faribor Sagigat. I'm the operating agent of Annex 23 of ECES. Let me first you about what is the International Energy Agency. Its organization has been established after 1973 oil crisis. It is a member of OEDC countries, and they were trying to sort of coordinate their effort to become less independent on the sort of fossil fuel. And they have a number of projects, and each one has different name. One of them is related to energy building and community, and the other one is energy conservation through the energy storage. And so far they had 23 annexes, it means 3 projects that the organizing member, sort of participating member are participating and work together to solve a certain problem. And one of the projects that was defined, it was applying energy storage in building a future, and we are not going to discuss about what it is building future. We had a presentation earlier this morning about net zero building energy, low carbon energy building, or so on. Therefore, the presentation here is, again, I'm sorry, I'm a little bit going against the recommendation of organizing committee. My presentation is a report, is not, but does not follow based on that recommendation of preparation of the presentation. One of the issues that we have with energy storage, that there is a sort of a strong recommendation that you use renewable energy resources like a solar energy, but they are sort of not, they are alternative sort of varying during the day, and therefore you need to have a sort of form of storage when it is available and use it whenever it's needed. And another part is focused on the sort of trying to reduce the demand. If you look at this chart, it's representing about the energy consumption in Quebec, that only during 3 days during the winter time when the temperature goes -35, they cannot provide enough energy for heating or cooling of the building during the winter. And that's energy needed for hot water, for heating of the building, and so on. And that costs almost $10 per kilowatt to generate, while they are only charging the customer 6 cents per kilowatt. Therefore, that's one of the effort here, is trying to sort of design the building in a way that they can sort of reduce the energy demand, energy during the demand time. What is the focus of this annex? It was trying to sort of define the ideal thermal storage system, and that's for the building of the future, and that needs, the focus of this annex was what type of technologies are available, what material is the best for using for application for thermal storage, what method of integration, if it should be used as distributed or sort of centralized, which technology is best and why, and how to design such system and assess its performance, what are the best tools for designing such system, and what are the impact of such system on the environment. Therefore, the focus of this annex was trying to answer to all these questions. The annex was divided to 5 subtasks.
We have also measured the power that the panels which are connected to the grid produce. Therefore, we can this way we can compare the electricity or the energy that we get from the panels which are connected to our system in comparison to panels which are connected to the electrical grid. In order to have the useful power that the machine gives, we need to measure the pressure, evaporating and condensing pressure, and also the 4 temperatures in the thermodynamical cycle. This way, we can measure what's the useful energy that the inverter unit gives. These, for example, are measurements, all the measurements this date, 24th July last year at 4 o'clock. This is 1 day measurement, and we did measurements several days.
These offices to test the occupancy model, presence, absence, the use of blind. But for the use of windows, opening windows, we haven't monitored data. That's the reason which we used a university classroom that is not an office, it's a classroom, but we have more details on opening windows. So for more details are available in the paper, and you can also contact me by email. So.
I'm able to represent in a suitable way the actual energy consumption. That is, I obtain a good model using active user behavior, medium user behavior, and passive user behavior. And as expected, when I have a medium, a standard approach from occupant behavior, I can reach more or less the standard of the building, and then I can also understand what is the difference between the standard behavior and 2 different energy conscious of energy unconscious behavior, applying this model in order to increase the capability of
Next day Here shows the forecast of the heating environment. Well, we can see that H3 is really different with the others. Since the H3, the inlet water temperature was 28 degrees, which is lower than others. And then the heat use coefficient of H3 is 83%, which means the heat loss decreased compared with the other indices, which is only 17%. But at the same time, let's have a look at QW.
That's all. I'm at your disposal if you have any question. Thank you.
Okay, thank you very much. Do you have any question? Question? I think no question. Okay, thank you very much again. And now, second speech is about the numerical investigation of the performance of a typical condenser. It is prepared by Erbay and Yılmaz, and now it's represented Professor Erbay.
Thank you.
Panel representatives of 5 countries will take place. Draft program will be revised and conclusive program will be announced within following weeks. We have been in contact with one of the invited speakers, Professor Allard. In each session there will be 3 papers. It will be possible to increase the paper numbers by parallel room sessions. Paper summaries, paper...
willing to listen to your presentation, so we have to do it on time. So good is sometimes not very good. So until 12:25, we have some time to stretch your legs, okay?